Okay, hi guys. So here is I-3, and let me read the directions. So f of x is a continuous function with selected values shown in the table below. Find the following approximations for the integral from 0 to 13 of f of x using the 5 subintervals indicated by the table. So the two sums that we're going to do are a left-hand Riemann sum and a right-hand Riemann sum. And when you hear the word Riemann, I think that's the guy's name who kind of popularized this method maybe, or did something important with it. But when you see the word Riemann, that means rectangle approximation. So think of it that way. So when you want, so here we've got, some function f of x, and the integral from a to b of f of x. What this means is the area under the curve. And this means actually like the exact area. So the exact area under the curve. But you can approximate the area under the curve, this blue area, by doing like a certain number of rectangles. But if you're going to use a certain number of rectangles, they're not going to fit the curve perfectly. They're going to go like over or under the curve. And unless the curve itself is a rectangle or a horizontal line. And so there's basically like 3 ways of using rectangles that we're going to do. That is a left-hand Riemann sum and a right-hand Riemann sum. Oh, and a midpoint Riemann sum. So what we've got is this table of values. So what you're going to want to do is you're going to want to do like a sketch of these points, like the way that I did here. We'll do a left-hand Riemann sum first. So I plotted the points, and because they told me f was a continuous function, I can connect the points. If we couldn't connect the points, then the integral is not defined. So for a left-hand sum, what you do is for each subinterval, you're going to draw a rectangle. And that subinterval is going to be the base of the rectangle. Okay, so this is the base of the first rectangle. Now, there are, the way that you want to determine the height of this rectangle is by going from some point on the base up till you touch the graph and then completing a horizontal line, to finish off the rectangle. And so what we're going to do for a left-hand sum is we're going to look at the endpoints of the first base, and you're going to use the left endpoint to go up to the graph. And then once you hit the graph from the left endpoint, you do a horizontal segment, and then you complete the rectangle. Okay, so the height of the rectangle is going to be determined by going from the left endpoint up to the function. All right, so that's the first rectangle. Second rectangle, here's the base. You go from the left endpoint up till you hit the graph, little horizontal segment, complete the rectangle. Okay, this is the third base because it's the third subinterval. And then I go from the left endpoint up till I hit the graph, complete it. All right, left endpoint again. All right, we're using this, that's the next subinterval. Up to there. Okay, that's the final left endpoint because we're on the final subinterval. Okay. Yeah, so guys, it is the area of each of these rectangles added up that gives us a left-hand sum approximation. And the more rectangles you use, the more accurate your estimate is going to be. Now, so we just have to find the area of each rectangle. Okay, so yeah, just do base times height. All right, so for this first rectangle, the base is 2 and the height is 4, so the area is 8. this rectangle, 1 by 9. This rectangle, that's 4 times 14. 4 times 14 is 56. The base of this 7 to 11 is 4. 4 times 27 is 108. And then this one, base is 2, height is 35. 70, 70, I think. Yes, 70. Okay, guys, so the left-hand sum, so according to this left-hand sum, the integral from 0 to 13 of f of x is approximately, and then I'm just going to add all of these up. 8 plus 9 plus 56. 70, let's see if that's what I got earlier. Plus 108 plus 70, 251. Okay, that is from a left-hand sum. I think that's what I got earlier. Yes, it is. Okay, now we're going to do a right-hand sum. And guys, feel free to like speed the video up. Okay, so right-hand sum, I start with the same graph, but, and this might be a good time to like, speed the video up or skip ahead, because I'm just going to do the same thing. I'm going to look at the base. I'm going to go to this time to the right end point up to the graph. All right. And then here is the base, right end point up to the graph. This base, right end point up to the graph. This base, right end point up to the graph. Last base, right end point up to the graph. Okay, and then, yeah, so it's going to be this area that's doing the approximating. Okay, so the right-hand sum is giving us, I'll just tell you what I got earlier. Yeah, 362. Okay, add areas of all rectangles, dot, 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 362. Okay, and if you feel like you need practice, like getting that number, then you should do it yourself, but that's what we get here. Now there is another type of way of determining the heights of the rectangles. So we're going to do one more little example. This will be short. So f of x is a continuous function with selected values shown in the table below. Find the midpoint approximation of this integral using the 4 subintervals indicated by the table. So from this table, I did a sketch, okay, of those points. The function's continuous, so I can connect them. And 4 subintervals, all right, 4 subintervals. So these are the, if I want to split, from 2 to 14 into 4 subintervals, these 4 subintervals, it would be from 2 to 5, 1 subinterval, from 5 to 8, from 8 to 11, and then from 11 to 14. And the reason they're giving you the function value for the midpoint of each subinterval also is because that's what we're going to use for the height. Okay, so even though they gave me like a lot more values than before, I still just have these like 4 subintervals for the bases of my rectangles. And guys, you might not feel the need to watch the rest of the video once you see maybe me do the first rectangle, but here is the base. And then to determine the height, you go from the middle here, 3.5, up to the graph, and then you do little horizontal segments on either side, like that, okay? And then base, up to the graph, little horizontal segments on either side. Shoot, I don't like doing that. Whoops. I wanted that to be dotted. Yeah, so I wanted these to be dotted because I want to show that it's like one rectangle. I mean, I guess you could do it in two, but all right, and then this one. Dot, 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 dot. Little segment, little segment. Um, 11. Huh. Oh, 12.5. That doesn't look like the middle. Sorry. 12.5. Oh, I guess this should be there. Oh, duh. Okay. Yeah, so 11 to 14. Oh, whoopsie. Okay, so this is the last one. And then from the middle, I go up and like that. Okay, sorry for that confusion. All right, and then when you add those up, you end up with 132. Okay, 132. Okay, guys, there's that.